Should be good. Alright, okay, so we got your directory here. Nothing in it. I don't know if you remember last time we did keep everything in version control.
What's that again?
It's just like we can keep like versions of the file so that if we make a mistake, it's easy to go back or whatever. We probably don't really use that, but might as well. Alright, so what we want to do here is just make a new directory, tic-tac-toe. Nothing in here. And then we'll make tic-tac-toe.py. Python, that's right. So this is just some food to tell the computer that this file contains Python, so it knows what to do with it. And just make sure everything's working. Right. That's always the first program you write. It's called Hello World. This is some stuff to tell the computer that that is a program that we can run as opposed to just like a file that we might read. And so now we can say good, and it prints hello world like we'd expect. Okay, cool. So alright, so now I get some structure to this. So how do you think we teach a computer to play tic-tac-toe?
Like you teach Tabby how to play tic-tac-toe?
Well, so the good thing about a computer is it's really good at following instructions.
And it doesn't bite.
And it doesn't bite. And it's very fast. So
And it's better at listening.
Better at listening. So if we wanted, well, let's actually, you know what, before that, let's...
Very stiff.
Excuse me. Let's start with, we got to figure out how to, like you said, we got to make the board, right?
Yeah.
So we could make a board easily enough.
By using like T's or something.
Well, I was thinking like this. Let's see.
But it needs to be very big.
No, it just needs to be big enough to see what's going on.
I guess, because...
So we could like print a board like that, right? And then when you play, let's see, maybe we should have two. Like that. That's good.
I was thinking of something a little bigger, but I guess...
Yeah. So one thing we can do is, and it's always a good idea, is like we can make the part of the program that actually knows how to play doesn't really know about like how to print the board or how to find out what move we made, and then we can use that same part of the program with some different way of, like maybe we'll make a fancy web page where you can see a board that's been drawn nicely, or I don't know, there's all kinds of ways we can do it.
Yeah,
but
like a very, like when we get to that, but we just started this out.
That's right, so we might as well start with something easy. So, oops,
What are all those number signs?
Okay, so that's a comment character, which means tells the thing that understands this code, that knows how to run it, that this is not part of the program. So it's useful for drawing, for putting comments to yourself that are only for the humans to read. Okay, and then I'm just drawing it here as like this is what our board's going to look like. So let's start.
Will it have those?
It won't have the comments. All right, that's just
because that's the board when we're using it.
Yeah. Okay, so we're gonna have a print board. So we're gonna make a function. And remember,
it's like a bigger. Right?
What's it?
It's gonna be bigger.
No, it'll be that size. We'll see. Okay, so print board. We're gonna pass it a board, which will be like the state of the board. But for right now, we'll ignore that. And actually, we can literally just take these comments that we wrote, and just for grins, we'll do this. Let's do this. I'm going to record a little thing here so I can say indent that, print. I am recording this. Okay, so now I have a function that prints out.
No, it's right there.
All those things.
Gonna print that out?
Yep.
Okay.
Alright, so let's see what happens. Okay, and so now we can come down. So this part of the program, this silly if name equals main blah blah blah. This is just a little bit of a sort of standard way to divide like the part of the program where you just define things and the part that actually runs. And so I had passed there before because I didn't do anything, but now I'm going to say print board, and we don't actually need a board, so I'll just say none. And so now, if we did everything right, look, no, well, we can't play, but it printed a board, or it almost printed a board. So we got something there.
The X is there.
I lost, I wanted 3 in each of those. Yep, okay, so now try it again. So this is the shell. There we go. Okay, so that's kind of cool, except
there's an X there.
There's an X and it always prints the same thing. And also,
what do you mean it prints the same thing?
Like, it always prints that board with that X there, and we totally ignored this thing that we passed in that should contain the state of the board. So let's,
what do you mean?
Like, so like, if you imagine, like, so there's an empty tic-tac-toe board, and then there's all the different ways you can fill it in.
Yeah.
And like, so the way that it's currently filled in is the state. So state means like, what does it mean? It's like the current situation. All right. Okay, so as you point out, we should get rid of this X. There's another thing that's kind of funny is that, especially now that we've gotten rid of the X, a bunch of these lines are the same, right? Like that one.
What do you?
Like, if you literally look at that line of code, and then that line of code,
they're the same.
And that line of code, they're all the same. So let's.
Why don't you just do it once and then do it like times, whatever.
All right. Except that the tricky bit is that then we have this other line where we print the sort of divider, and we do that twice. So let's do print row.
Let's print row.
So it's going to print one row, and then we'll make another one. Def print divider that prints the divider, and then we can rewrite print board to be print row. And again.
Why not reprint it?
Well, so eventually we're going to have to pass in the row that's going to tell us whether, like, is there an X or an O or what's there. But at the moment we haven't.
In the computer.
We'll tell the computer, right?
So it knows what to do.
Right, so
and it doesn't go where we've already gone.
Right. So now, it's still kind of duplicated, but at least for, like, if we decided to change how we printed this stuff out, it would be different. Like, we just change this row, and it would all the rows would now print out the same way. So that's a little better. Let's just see if that still works. Yep. Okay, cool. Okay, so that's now. In fact, we can do this. So let's say, okay, so now we're going to think a little bit about how are we going to represent in the computer the state of the board. Remember, the state is like where the people have gone, where the computer has gone. And so there's a bunch of different ways we could do it. So one way is, actually let me just go over here. So we can also run Python just interactively. So we can say the same thing we put in our program. And it'll print it. So one way, well, how would you represent? Like if you had to tell someone, like you say you're in the middle of a tic-tac-toe game and you wanted to write it down where you were, but you didn't want to just draw the board. Like if you wanted to, that's kind of a silly question because it would just be easier to draw the board.
Yeah, but
But say you had to write it on a single line or something.
Well, like in chess, you can like when they were playing blindfolded, they could tell where the like where the pieces were
Right.
like
So that's an
by,
idea. So what if we had, let's go over here.
like they're each numbered.
Right. So what if we?
Can you just like make a little board and then we'll number it?
Yep. Good idea. So make a board. Actually,
But that's a silly question, because who's gonna?
yeah, we'll run our thing, and here's our board.
And then we just number it and letter it.
So actually, let's do this back in our program. We need this because we have our little drawn board. So basically, if we said like 1, 2, 3, 4. So I'll tell you a trick. Computer programmers always start numbering with 0.
What?
Well, actually, I'll tell you in a moment. But so let's if we start from 0, oops, and this is 5, 6, 7, 8. Okay.
And then once you move, it replaces the number with your X or Y.
That's right. So I'll show you now the reason back over here in Python. We can make a list in Python. It looks like this. X equals
X equals human.
no 1 4.
It means that you can't go there.
All right. So we can make. So this is a list of none, 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 none. And there's a thing you can do. You can get certain elements out. So actually, let me do this. I'm going to make X equals list range 9.
But you did X.
So actually, this is kind of exactly like if you took our board and just wrote out the numbers. Then we have the numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, right?
Mm-hmm.
And so here with X is actually what's called a data structure, and so we can get out a particular value. Now in this case, it's kind of silly because the values are the same as the number. But so let me show you if we did X equals list A, B, C, D, E, F, G, H, I. Now we can say X and those square brackets. That means gets the second thing out of X. What do you think it's going to be?
B.
Almost. C. Remember, we number from 0.
Oh.
So X0 is A, so 0th element. X1 is B, right? All the way up to X8 is I. And if we say X9, anything's going to happen. Because it only goes up to I.
Oh, say I don't know.
That's pretty much what it said. This is how it says, I don't know. Index error. List index out of range. So this number is called the index. It's like how the thing you look it up by. And since our list is not that long, it's like there is no ninth element in this list. Okay. So that means we could actually represent this board with a list of 9 elements, index 0 through 8. And so we could do, let's do this. New board.
Why? This is kind of weird, but instead of like typing it in on the board, you could have like a list of numbers, and then if you're like, you would pick one and then like delete that, and then it would get deleted on the computer's list too, and then the computer would put your mark on the board.
Yep. You could do that. So they keep a list of where you have moved.
Yeah. Or no, where's open.
Where's open.
Like, so say you had moved on 2 and I moved on 8.
Yep.
And then those wouldn't be on your list, and then you could pick any other.
So that's an excellent point. So we could keep a list of all the places you moved, but then we'd also have to keep a list of where each player had moved, right?
I guess. Why?
Well, because, so think about, later on we're going to have to know, like, the computer's going to have to be able to know whether someone's won. I guess we haven't really talked about what this program is going to do, but I'm assuming this is going to be, like, you'll play against the computer, and so you'll enter your move, and then it'll enter its move,
and then we could make it if it could figure out if the computer won, it would say I won, and it didn't. It could say you won.
That's right.
And then we could teach it how to say good game.
That's right. Okay, so let's just go with our initial plan. Like I said, there's a lot of ways we could do this, but so we'll make a new board by, actually, so this is kind of silly, 9 times 9. Oh, what? Oh, crud.
What happened?
Sorry, I accidentally launched this stupid program with a magical.
Magical flag.
There we go. Some of these special key commands, they mean things to my editor, but they also meant something to that program that I had running by accident, which I didn't want. Okay, so new board. So this is a little bit of a funny thing. So we're making a list with just one thing in it, and then kind of funny. So the star is how usually computer programs write multiplication. What do you write multiplication with in math? It's a little X, right? Yeah, so there's no X on the keyboard, so we use this asterisk because it looks kind of like an X.
Yeah, there is.
Well, there's an X, the letter X, but that's actually, I'm sorry.
Confusing?
Yeah, because letters usually are something else. You need like a special symbol. Anyway, so we use that little asterisk. And if you multiply a list, you get a list as long as you've multiplied it. So we're getting a list of 9 nuns. So basically what we're going to do is we have like an empty board. There's nothing in any of the positions.
But there's 8 spaces.
That's right. They're actually 9. 0 through 8. Okay, so that's kind of cool. So now, now there's a little bit of a funny thing. When we tell it to print a row, we only want it to print 3 of the things, right?
Yeah, I guess. Right.
So, how about, okay, so let's do this. Let's change row. So we give it, well, we're gonna implement it down here. So print row, and we will give it a list with just 3 things in it.
Okay.
And
like 1 to, like 0 to 2.
Exactly, 0 to 2. You're catching on. All right. And so this is a funny little thing.
Isn't that what I'm supposed to be doing?
Catching on? Yes, that's exactly what you're supposed to be doing. So format. So these little funny squiggles basically are a special thing that this format will then take the arguments that we give it and stick them in there.
What do you mean arguments?
So when you call a function, like we called print board, and this name board here, is like someone's going to pass something in. Those are they're called arguments. I don't know why they're called arguments.
You're not arguing.
No, it's a different kind of argument. Okay, so if we now define print row to take a row, which is a list, and stick those things in, then
0 to 2.
so let's just try this. Actually, let's say row equals none
No, it equals 3.
times 3. That's right.
So none times 3, which is 3 times.
Okay.
There.
All right. So let's try our program. See what happens. Whoopsies. What's that? Syntax error. Line 23. Oh, come on.
What's syntax?
Syntax is just the rules about how you put together your program. Like, okay, so here's the problem. So we have print, and then we have this opening parenthesis, little curved thing, and then stuff in quotes, and then format, and an opening parenthesis, which is matched by this one. So those two go together, but we never closed, and so then the Python, the program that understands our program, without that closing parenthesis, then all of a sudden when it hit this def, that doesn't make any sense. That's not a legal thing for there to be there. It's kind of like when you write text. You have to capitalize the first letter. You got to put a period at the end of the sentence.
But people can read it.
So people can read it, but computers are much more picky. So,
that's the bad thing.
It's exactly the same thing. That's called syntax in writing as well. All right. Oops. Now. Oh, oops. I misspelled something.
What?
I wrote now instead of row. All right. Oops. Well, that's kind of right. Except it said none, none, none. Probably we should leave it blank. Instead of put it in there. No,
it doesn't look like a tic-tac-toe board.
That's right. Okay, so we need...
It looks like one of your weird things that I don't understand.
Let's see if that works.
Why do we put...
Oh, close. Did you see it? Okay, so none is a special, is nothing, right? And so this is actually kind of like English. If you say nothing or something, this or means if this thing was something, it would just give you that.
So we need to put or everywhere?
Well, just here. And so
why not, there?
Where?
There.
Oh, up here? Oh, because is where we actually want the nuns. It's just here instead. Like when it's a none, if it's a none, we want to actually print something else.
What do you mean?
Actually, you know what? This is silly. We don't really need. Well, so we could fix it here instead of using none. We could use a string of a space, and then this would be the same as it was before. Oops, what happened? Oh, sorry. Except my row is defined somewhere else. Okay, there we go.
I like that. It works.
So that looks good. Okay, let's do that. So we'll decide later what that means. Okay, so that's cool. Except
I don't really understand what was the problem.
The problem is basically that it was just printing none because the way none is a special value and the way it prints it is as the word none, but we don't want that. We want an empty space to hold the space in the
So wouldn't you just not write none and leave an empty space?
Yeah, but well, that's what you would do, but you got to tell the computer to do that.
Well, yeah, that's what you...
So before we had said print whatever's in the row, but what was in the row was none.
Well, you could have just left it blank.
Yes.
In the row.
So that's what we did now. Okay.
That makes it work. That's what I was saying.
Okay, good. So we're all good there. Now, so just for grins, let's make our row be X instead of empty. Well, and now we get a board all full of X's, right? So
X wins.
X wins.
So we can kind of just play around and put whatever we want in.
Right. Okay, but so now...
You could put Z.
You could. I'll try. Put Z. Oops. Except you gotta type it right. Z. Z. All right. But let's... Okay, so that's if we want it to be blank. So our board should be blank. But okay, so when we... But so here, inside print board, we just defined row to be empty, but the whole point is we're supposed to be printing the board that we were given, right? Like this board that was passed in.
What do you mean? Passed in by what?
So like when we, so now, let's do this. Board equals new board.
So we take board and we get a new board?
Yep, so that's this function up here. So you can see that it has these parentheses, don't have anything in them, so it doesn't take any arguments. So we just, every time we call it, it makes a new board for us. We can actually print the board with just a regular Python print function. And let's see what that does. And so this is how Python prints out a list. The list is full of spaces.
That's a funny list.
And then we can pass that board into our function. So let's and just for grins, let's take board 0, and now we'll put an X in it. So this is, remember before we could say like with the brackets to get the nth element out, the 0th element or the first element. You can also put things into the list. So here we're saying the 0th element of the board is now X. And so what we want is when we pass the board.
So you mean like that part?
Well, it corresponds to that.
Yeah, so in that space.
Yep. Yep. Okay, so now the problem is that when we print the row, we want only the elements like the 0, 1, 2 of our whole list. So we could just do this like, actually.
Oh, I know what we could make a list out of. Instead of doing a list of numbers, we could have a little tic-tac-toe board like that. And then it could show us.
Well, so the problem is there's no particularly easy way in the computer to represent like that sort of graphical board. And we could represent it as a whole big string, but then it would be hard to manipulate in the program. Like when we wanted to find out, has someone played in the 0th position of the board?
You'd find out because it wasn't there wouldn't be a 0 there, which means you couldn't play in the 0.
Yeah, but so if that was a whole big, like, how would you know what, like,
who played in it?
No, not who played in it, but like just if this was a big long string, it would be. Yeah, maybe I have to trust me on this one, but it would be. There's no way to say like exactly that spot in this big blob of text. What's there? I mean, there is a way, but it's kind of convoluted.
Well, we could just play like normal tic-tac-toe, kind of.
Well, we are. We're just. I think so. The key thing that's going on here is that there's one sort of concise, easy to manipulate representation of where everyone has played, and then there's how we show it, and they're not the same thing. Kind of like when they were playing chess in that video, like the board that you're actually playing on is the representation of what has happened, but there's also the list like of everything in his head, right? He was playing in his mind, right? So he had some representation in his mind of where all the pieces were that's separate from the board that's in the world. So same thing. The computer has in its mind, in quotes, some representation of what's gone on, and then there's also it can show you what that would look like. Okay, so I'm gonna
so
go.
So like kind of use it as your brain.
Kinda. So I'm gonna do a little trick here. Cut ahead.
A magic trick?
0, 1, 2, 3, 4. Let's see. I think this goes there. 3 to 6. Actually, we can check over here in Python. So Python 3. X equals list. B, C, D, E, F, G, H, I. There's X. So this is, so remember how we used X and the square brackets to get the 0th element out? We can also get a part of the list out. So 0 through 2 is basically the 0th element and the first element, and then not the second. So if we want the first 3, we can go like that. And then we can go 3 to 6 to get the middle 3. And X 6 to 9, GHI. Okay. So that's good. 0, 3, 3, 6, board 6, 9.
6:09 o'clock.
No, 6. The colon means it's kind of, so when we're talking about syntax, this is special syntax that means, so instead of getting one element out of our list, we're going to get a range out of the list. And in this case, it's going to be the 6th element, the 7th element, and the 8th element. So starting at 6 and going up to just below the second number. So 6 to 9, 6, 7, 8, not 9. All right, so now, actually we can do this. We'll comment out that and make the board the way I've been making it in our little REPL. So just so we can see, A, B, C, D, E, F, G, H, F, G, H, I. So board is a list with 9 things in it, and so we should be able to pass it to our print board function. Maybe, if we haven't messed anything up. Okay, you see what happened? So it put all those items in the right place. So
now what are we going to do?
So now, but we don't want those letters there, so we want to go back to having a new board. Let's try that, see if it prints out an empty board. It does. And then if we put back this, where we put a mark, and so where do you think we would, if we wanted to, so say O is going to go next, and we want to put an O in that bottom right corner. How would we do that in the program right here? So this line, put an X in the top left corner. Now I want to write a line.
9.
Almost.
8.
Yep.
But I thought you started.
Yep. 0, 1, 2, 3, 5, 6, 7, 8.
But it's the 9th number.
I know. This is the confusion about starting at 0. Like I said.
But you said that you start at 0.
Right. So if you start at 0, this is why it gets confusing. The 9th number, if you start at 0, is 8. Or just like the second number is 1, which is very confusing. So now, oops, if we say board 8 is 0, is O.
See, but then there you start, but there's 9 squares on the board and that's the 9th square.
Right, and so if we numbered it from 1 to 9, it would be 9, but we number it instead, shift everything down 1, and it's 0 to 8.
So but then you're confusing me because sometimes you use 9 and sometimes you use 8.
Oh, you mean up here?
Yeah.
This one? Yeah, so that is a kind of funny thing because we're saying it's just...
Before when you were showing me the alphabet, and I thought you're confusing me.
Okay, well let's see if this works, and then we can, if that puts it where we think, or where I think. Okay, so it does put it down there. And that is, so we have this diagram up here, right, this? So that tells, so these numbers in that diagram tell us the numbers that correspond to each.
But you're confusing me because when we were doing the ABC, and then you said that one.
Back over here.
Yeah, no, not that far there. There.
This?
Yeah.
What about it?
0.
So 0 is A.
2. And then, but you 3. Wait. This is confusing.
Here, let me.
Look. 3 is D. It's 0,
0, 1, 2. Yep, 3 is D. That's right.
No, 1, 0, 1, 2. But you started at 0 before you. Oh yeah, I guess. But it's really confusing.
Yes. So this is a confusing thing because most people don't start counting from 0. So this is just one of those things. And there's even some programming languages that do it from 1, and there's reasons for that too. But this is one of those things you just gotta. Okay, so we've got a thing that can print a board, where the board is a list of 9 things. And so we're going to use this idea that, and this string with 1 space in it represents no one has played there yet, and a string with an X in it is X has played, and a string with the O in it means O has played. Okay. So now, what else do we need? So we've got a thing that can print a board, and we can make a new board. So now what do we need?
We need to be able to play.
Yep, so there's a couple things we need to do. Actually, let's make a list up here. Okay, so human makes a move, computer makes a move, and we had said that the computer can tell if the game is over. All right? And so like basically, we'll make a move, the computer will make a move, the computer checks if the game is over. If it is over, says who won, or if it was a tie. All right. So let's do the first one. Make move, board, and for our move, we can just use one of these numbers, right? So that's actually pretty easy. Just that code that we had before. And when we're playing around, oh, and we need to know. Sorry, we need to know. So this, I guess, this function will work for either it just makes the move on the board. Okay, so now we can actually try that out. Make move board, go in the middle, 4, and it'll be X.
And then, how do we teach the computer to make a move?
Okay.
And how do we teach the computer, like, how to win because of the computer?
All right. Okay, so let's go over, this is always a good thing to do when you're programming, is if you've already solved the problem once. So when we did our 20 questions program, remember we had this whole, because we had to ask the human for stuff. So this time it'll be a little easier, because we just need to ask for a number. But we can look at, so where was def ask? There we go. Input.
What's input again?
What?
What's input again?
If I remember correctly, we'll try it over here. So input to our move.
Input is your move.
So input is a function that is part of the language, where it basically prints out whatever this string is that you gave it, and then waits for you to type something, and then actually returns the string that you typed. And so I think in Python, good. So we want to take that string and turn it into a number. So go back over here. can say get human move.
It looks like a sad fish.
It does look like a sad fish. Or maybe a frog. Alright, so how about, so for the human move, we should probably print the board. So we'll print the board so the human can see it, and then say input this. Okay. So let's try this. Let human move. This won't actually do anything. Oops.
Why?
Because we didn't. So it showed the board and asked what's our move. So we just have to know the number. So let's say 4. Cool, but it didn't do anything with it. But this.
We need to teach how to use.
That's right. So we can say make move. Actually, let's do this. So get human move. So it'll get the move and then make the move on the board. And we'll just say that for now the human is always X.
The step down is human. Doesn't X always different?
Let's see what happens now. So it prints the board and says, what's your move? We say 4. Oh, and then it prints the board again with our move made.
And then, should we ask it, what's your move?
No, it'll just go ahead and make it. So actually, what we really want to do, so now we want so the computer is going to move.
Okay.
So what would be like a, I'm going to change get human move to just human move. So what would be a really simple way for it to for the computer to pick its move?
Pick number, and then you could do a list of numbers that could pick.
Right, but so it has the list, like it already knows the list of numbers.
Pick number.
So just pick any of a random number. Okay, so there is.
Then we have more chance of winning.
From random import range. I can never remember.
I'm hungry.
You want to take a break?
Yeah.
Okay. So let's see.
Why are you doing that? Can I go get a snack?
Let's take a break if you want a snack.
Okay, no.
Okay, so we just want to pick a random number between 0 and 8. Is that your plan?
Mm-hmm. Except not 4.
Why not 4?
Because we moved it.
Oh, so we should. Oh, well, we don't always move at 4, so we should.
Well, I meant
When it's not taken, right?
Yeah, because like in tic-tac-toe, you can't. That's only in gob.
That's right. Oh, I think we can make a gobbler game. All right.
Awesome.
Okay, let's do tic-tac-toe first. Okay, so the computer needs to pick a number from 0 to 8 that hasn't already been played.
Yeah.
Okay, so we have a list in the board. So there's a couple ways we can do this. In some ways, the easiest is left equals
and then, well, I was thinking we could make a list every time we move. That's kind of like a waste of time, making a list of numbers computer can choose from, I guess.
well, but the computer can make the list for us, which is sort of what I was about to do. So I was going to say, well, let's call it possible moves equals I. I is what people often use to refer to an index.
Oh, I thought you meant like I.
Okay, so for I, for I in range 9.
Because there's 9 numbers.
That's right. So range returns returns exactly what we want. A number, all the numbers from 0 up to just below the number you give it. Or another way to look at it is it gives us 9 numbers starting at 0. So again, that's going to be 0 through 8.
Because the way
Because
runs.
yes, because the way computers are.
It knows that 0.
All right, and now we only want
it doesn't get confused.
The numbers if board of that is not equal. Did we do this last time? Exclamation point. So,
equals not?
So exclamation kind of means not, and exclamation equals means not equal to our empty. So we can actually just check this out and say, hey, I got these possible moves.
Out loud making the computer say stuff. Put the imperious curse on them.
It's like you put the imperious curse on them, yes.
I'm reading the core.
I see.
All
right, and
well,
so
the fake matter, maybe.
Possible moves. So now I think there's a choose. Okay, let's take a break here and pick that up. We'll take a little break, have a snack, and then go. All right. Okay, so what were we trying to do over here?
We're trying to. What were we trying to
Okay, so we're implementing the computer move. So let's just start and see if we got then we'll human move, we'll move, and we'll call computer move.
So we type that in. We type in computer move.
No, I added, like right here, I added a line. So our program is now we make a board, then we call the function that asks the human for a move, and then we ask the computer to move, call the function that makes the computer move. Though actually it doesn't move right now, it just prints out what moves it found. So that's basically we'll stop there. So we're going to say let's do 3 this time. And it got exactly the opposite. I totally reversed it. So possible moves are the ones where the board is still empty. And so we use this funny double equal sign, because when you use in Python, when you use the equal sign, that means make something, like assign it. Like here we said move equals this thing. But if you want to test whether two things are equal, you use equals equals. Okay, so now if we do it again, tic-tac-toe, we'll move here, and it got 0, 1, but not 2, 3, 4, 5, 6, 7, 8. And now we can go.
Oopsies.
No, I meant to do that. Open up Dash. Dash is a documentation browser. Choice. There we go. So there's a function in random.
But don't we have to keep going to finish the game?
Yeah. Okay. So so now we're gonna implement, so the computer got the list of moves, and then it can choose one of them. So move equals
what is
choice.
Equals again?
It's assignment. Basically says make move equal to. So move is I don't remember where we talked about variables.
No.
Okay, so a variable is something that can vary. It's a value. It's a name for a value. And in Python you can assign different values to it. Okay, so choice of possible moves is going to be one of the numbers. So basically it's going to randomly choose one of the numbers in the list of possible moves.
Not randomly choose. I'll just do choose. Wait, then it's not really playing tic-tac-toe.
Well, it's playing legal tic-tac-toe. May not be playing very good tic-tac-toe, but that's our. I mean, we can make it smarter later.
Okay, well, I'll start with this. Think of me like.
All right, so we'll move again at 2, and then it chose 4. Okay, so now we want.
But don't we go again?
Yeah, so now we need. How do we remember about loops? So a loop is what it sounds like, something that goes in a loop.
A circle.
So we can do this. So let's do.
And then kind of reuse.
So
While.
So while is a loop that. So we could do this. Let's just for grams, we'll start here. While true, so that's like while something, and in this case, true is always true. This is going to loop forever. Do a human move on the board, then a computer move on the board, and then print board. Actually, we don't even need to do that because human move will always show us the board. So this will let us play, kind of. So
But then how we're going to teach it how to say who won.
Yeah, but so then we're going to have to do some other things too. Okay, so now we're going to make a board, and you can see that this is actually all the same stuff we have in that loop. So now we're going to just say, let's call it play game on the board.
Do you think we should also teach it to play tic-tac-toe? Teach it how to say that.
We can do that. All right. So now, it's a little suboptimal that we got to remember the numbers. So here's a problem.
What?
So we're about to win. That's at 4, 5, 6. Except it doesn't notice that we won.
Yeah.
So now we'll
teach it.
So now we'll go at 8, and then we'll win again at 5. Oops. And then blammo, what happened?
There's an error.
Kind of an error. Oh, that's pretty gross, Python. But so the problem happened. You can actually see it tells us where the problem was. Line 53, no, not there. Line 48. Computer move, line 28. It's when we ask it to choose, and we'll probably notice here it said, hey, I got these possible moves. Oopsies, there are no possible moves because we had filled in the last square.
So what?
And so then when that library function that tries to choose out of a list, it explodes when it, as it actually says here, cannot choose from an empty sequence. So none of that would really be a problem if we had a way to tell that the game was over in the first place. So that maybe we should do that, huh?
Yeah.
Okay. So here's game over. Board. All right. So how is a game over?
There's 3 of something in a row.
So
Well,
turn 3 in a row.
return?
Because this function is game over is a function we're defining that we're going to call to say, is the game over? And it's going to return true or false. And so 3 in a row is one way. There's another way a game can be over, right? It's a tie.
The whole board is full there.
Right. So 3 in a row or possible moves.
There's no possible moves.
Len is short for length. So we don't actually have this. Up here we just computed the possible moves. So this is, it looks like it might actually be handy to break that out into a separate function. That given a board tells you all the possible moves. And so now that will do the same thing, return. So when you ask what are the possible moves for this board, it returns this funny thing, which is basically a list of all the numbers, the indices that aren't occupied. And so now, now we need to write 3 in a row.
And
that's going to be harder. Okay, so what are the ways you can have 3 in a row?
We got 3 in a row.
Right, so there's the rows, and then there's also the columns,
and the diagonals.
2 diagonals. Okay. So we kind of had the row thing here. Remember when we printed the... So let's see.
So we can number the rows. Like row 1, row 2,
yeah,
row 5.
5.
Well, the
Right. So there's actually a couple ways to do this. So one, let's just kind of brute force this for a sec. So the rows are there's 3 rows, right? 1,
2.
And so let's make a list, and the elements of this list will be themselves lists, or actually in this case ranges. Let's see how we do this. Python 3. So we remember before we did range 9. So that's not so useful, but if you make a list out of it, you see. So you can also do range like 6 to 9, and that gives you 6, 7, 8. So it starts at 6, goes up to 9. So the rows, there's actually there's one row that starts at 0, one that starts at 3, and one that starts at 6. So we can just
3.
So there's like 0 to 3, which is 0, 1, 2. Range 3 to 6. And so these are actually, you see, the same.
Wait, what do you mean 3 to 6?
So start at 3 and count until you're about to get to 6. So 3, 4, 5, but not 6.
So there's 3 rows.
Yep, and then there's 6 to 9, which is 6, 7, 8.
And 9 to...
No, that's it. So that's the rows.
Okay.
Then we have columns. So columns work another way, which is like, notice so 0, 2, 3, 6. You notice how that's like counting by 3s? Like 0 plus 3 is 3, 3 plus 3 is 6. Same thing over here. 1 plus 3 is 4.
Wait, 1 plus... Why 1 plus 3?
Because every time we go down, like to go down and get into the same column, you have to, if you think of it going this way, you start at 1, and then you go 1, 2, 3 to get to the same column. So
1 plus 2 is 3, and then 3 plus 1 is 4, and then 4 plus...
So if you just read the column 1, 4, 7.
1, 4, yeah.
That's like start at 1, And then add 3, what do you get?
4.
And then add 3 to that, what do you get?
9.
4 plus 2?
Oh no, 7.
That's right. So 1, 4, 7 is this like sort of counting by threes, except that
And then
you start
2 plus 3 is 5. And then 5 plus 3 is 8.
Yeah. Okay. So it turns out over here, this range function that we were using before, you can also do range 1 to, I think it's this. All right. So you can call range, and the first argument is still the number to start at. The second argument is the number just one above the highest number you'll return. And if you pass a third argument, it's the size of the step to take. So normally you just take a step by 1, but in this case, so you can see if we
Picking a 7. 3.
Right, so if we do range 0, 9, 3, then we get 0, 3, 6, because 6 is the last number that's, like if you added 3, you'd get 9, and we don't want 9. And the same thing, if you list range starting at 1 up to below 9 and counting by adding 3, you get 1, 4, 7, which is the other column. So we can make these range 0, 9, 3, range 1, 9, 3, range 2. And then finally, diagonals are a little bit funny. I don't know if there's really a great way to do that.
It's 2 plus 3.
So it's 0. So this one is actually easy. It's counting by 4, right? 0 plus 4 plus 4. So
and then the other one's counting by 2s. 2, 4, 6.
Oh, good point. Starting from 2
to 4.
So in this case, we want it up to 7.
Yeah.
Counting by 2s. Nice. I didn't even notice that. I think you can also do.
You can like ask it what it's counting by.
No, I was wondering if you can do 6 to 0 by negative 2. 6 more 2. Yep. So either way, 2, 4, 6. We'll go with your way.
Right. My way.
All right. So now we have an all. I don't know. What do you call? Let's call them lines.
What line?
A line is like a row or a column or a diagonal.
That's what the computer's gonna learn them by.
Well, we're just diags, print lines. We'll just print that out and see what we got. Blammo. What?
What happened?
Oh, sorry. I want to syntax it over there.
Can we play?
So I've got 0 to 3, 3 to 6, 6 to 9. So these. Okay, well, kiddo, we've gotta. Okay, so now that we've got all those lines, we could ask of a single line and the board, are they all the same value, right? So one of these rows, like the range 0 to 3, is essentially the 3 numbers, 0, 1, 2. And so the way to check whether that row is a 3 in the row, and given the board, is to get the 3 values, 0, 1, and 2, and ask, are they the same? So we have, like we can, let's see, how do we do this? Let's call it pieces equals board, let's see, board I for I, sorry, let's make another function here. Diff. Why don't you, alright, we'll pause. Can you let Lonnie out anyway? Okay, go ahead. Okay, so, where were we? Okay, so what I was going to do, I was going to rename that. So 3 in a row, we'll take a board and a line, one of these things we defined up here, and tell us whether that particular line is 3 in a row. And then we'll have a different one has 3 in a row that just takes the board and will somehow tell us if any line has 3 in a row. Okay.
Oh, like, say, like, games over or something.
Well, that function will just is sort of for the computer, but then we can have it, then like, we have to decide later what to, actually how to interact with a human being.
Yeah.
Okay, so the pieces.
Try it out?
Yeah, but we gotta finish writing this code.
Oh, I thought we were finished.
No. Okay, so the pieces in a line is a list of numbers, essentially.
Isn't a line a column?
It's a row or a column or diagonal, and they are all these ranges of numbers.
That's what I meant.
Yep, and so we can walk through each of the elements of the numbers and then pull out the piece that's on the board at that number, and that's our pieces. And then, now all we need to do is say, are these all the same?
The computer's supposed to do that, right?
Yep, right. And so there's actually, so we've been talking about a list, like a list. It's like a grocery list. You put things on it. So there's another thing in math called a set. And a set,
like a set of numbers, like a triangle fact family?
Kind of. So that in this context, a set is like a list, except each thing can only be in it once.
Oh, I think we talked about this.
You might have talked about this in math. So, and that's kind of handy because
no, I mean, we were doing
when we did before. Right, so the nice thing about a set is that, so now we're going to pull these things out, and if the set ends up being, let's see.
Like, not a set?
Well, let's do it as a list first, and then if pieces
equal.
Actually, I think
I
there's
keep forgetting that.
Alright, all are true. Trying to see if there's a simple way. They're all the same. I don't know if they're the same. Or we could do it this way. So, how about this? Return pieces 0 not equal to empty, and pieces all. What's it? All so basically, this is a little bit of a kind of silly way. So first thing is, so we've got this list. That's going to be a list of 3 things.
3?
Yeah, because every line is 3.
Oh.
3. That's what we're checking, right? 3 in a row.
3 spaces.
And so one thing is, so 3 in a row is checking really 2 things. One is that there's all 3 of the elements of the line are the same, but also we don't want to count it if they're all empty, right? That doesn't count as 3 in a row.
What do you mean? If they're all the same, but they're all empty?
Then that doesn't count as 3 in a row, right?
Yeah.
Game is not over. So that's a possibility, right? If you took like at the beginning of the game, get the first row, pull out the 3 pieces that are there, and it's just the empty, then it would be like, that doesn't count.
Yeah. And if 3 are occupied?
Right. So basically, this kind of a right. So what we do is we get the zeroth, the first thing, and if it's empty, then we know it's not 3 in a row. But if it's not empty, then it's either an X or an O. And then we check that all of the pieces that we just pulled out are the same as the first one. And so if they're all the same and they're not the empty one, then that's what we mean by 3 in a row. So then we can use that same all function to check that all, let's see, has 3 in a row, so not any 3 in a row
with something in it.
So now we have our whole list of all the different ways that you can have 3 in a row, and so has 3 in a row.
Well, yeah, I can only do those ways.
Right, so we basically, for lines, and lines is the list of all of them. For each line, we're going to check 3 in a row on the board with that line. And if any of them are true, then that means there's a 3 in a row on the board. So I think maybe we're kind of close. All right, so while not is game over board, let's see, this might actually be done. Tic-tac-toe. What's your move for, oops.
What? What did you do?
Well, that was unfortunate.
What did you do?
All right, so let's see what it says. I got these, so here's our little printout. I got these possible moves. Remember how I used to print out a list? Function, possible moves at OX10071B32. Okay, that's clearly something gone completely, and I think I know what it is.
What happened?
And then, actually, if we look down at the bottom here, it says type error. Object of type function has no len. And we can go right
What's
to
a len?
remember that function we used? Len, short for length.
Oh, right.
I think what happened, remember I pulled out possible moves as a function?
Yeah.
So that it used to be we used to capture it as that was the name of a variable.
Maybe we should put it back like that because
well, we want to. That's a good strategy, but I think another problem is we need to use that function.
Oh, obviously.
Let's check it out. Cool. Oops. Okay. Now I got the list. All right. So now it's somewhere else. Oh, gotta use it everywhere. There we go.
Okay.
And while we're here, well, I need to pull that out in the variable. Cool. It moved. We'll go at 0. Now, you want to win?
Yeah, let me see what happens.
And then it worked, right? It stopped the infinite loop. Didn't show us the board, and it showed us its thing. Can you go let Lonnie in? Can you come right back? Okay, so if we look at our loop, we check at the top of the loop, is the game over? And if it's not over, then we ask the human for a move, and then we ask the computer for a move. So that's actually, part of the problem there is, so what happened, so one problem is we shouldn't ask the computer for a move if the game is over, right? So we actually need to check both places. So really, in a way, you might want to go back to an infinite loop.
No, we're going.
And then say, well, here's what we do. So like if.
But then it won't stop.
If the game is over, so there's a way to get out of an infinite loop. So if the game is over right before the humans move.
It will stop.
Oops. Well, So we'll have to be a little more subtle, but let's just say game over. And then break is how you get out of a loop. So otherwise we make the human move.
Make the human move. We're actually kind of making the computer play.
And then let's, if we break out of the loop, we'll print the board one time to see the end of the game. I think this might.
Why are you sneezing?
Yeah.
Did you get something in your nose?
She may have. Alright, there we go. Just pause this.
Because she's been sneezing. Good.
Okay. So tic-tac-toe. It's our move. We'll go corner. All right, let's go on 4 now. Go on 8. Game over. So that worked.
Yeah.
Let's play again and see if we lose.
Yeah, try it on and make the computer.
And unfortunately, the computer is going to play kind of randomly, so it might be hard to.
Well, let's just try to make it. Try ourselves not to win.
0, 1, 2, 3. Okay. How about, let's see if we can force it to win. I think it's already kind of sunk. Let's go with that.
What?
We won.
On accident?
Yep. Okay. But I think, so part of the problem is, okay. So let's do this. Add this.
There's so many little kids that come by our house because they're taught and it's so weird.
All right. So what have we got going on here?
A lot of writing.
A lot of writing. So 3 in a row has 3 in a row. Okay, so one of the things is like, maybe what we should do is.
It's very hard to lose.
Yep. Also, it's kind of annoying that we have this duplicated is game over, and also when it knows the game is over, it doesn't know why. Like we don't know that it's someone won or it's a draw.
It just knows that the game's over.
So let's do
because
this.
we told it that.
So let's do this. So let's do.
Probably doesn't even know what the word win is.
Yes, but we can define it. So let's define a winner, function winner that takes a board. And so.
A winner is someone who won.
Yes. And so this function is going to return either x if x won, o if o won, or none if no one has won yet. So do you think we can build that out of some of the pieces we already have?
Probably.
Like how do you tell? So how would you find the winner on a board?
By looking and see, and what got 3 in a row.
Right. So we have a thing to check 3 in a row. We have this has 3 in a row that just checks all the lines. So maybe the winner is more like that. So what if we did this for line? No.
Well, when we're playing, basically.
All right. So we have all those lines. So for line and lines, and this is like for each line in all the lines, we can we have this function 3 in a row. If 3 in a row on the board with that line, then we can return.
Return what?
So this is. So remember, this has happened twice now, where in some function we've defined a variable that like pulled some values out, and then later realized, oh, it'd be really handy to have that as a separate functions. So pieces takes a board and a line, oops, and just returns all the pieces in that line. And now over here we got to obviously do this right.
If you do anything wrong, it's not going to work.
That's right. So, but because remember last time when we pulled the function out,
we didn't use it.
We didn't use it in the place we had pulled it from. Okay. So now used it in 3 in a row, but we have it here. Can you get that chair situated? Good stuff. Okay. So now basically what we're going to do is a little bit inefficient, but for each line we'll check. If there's 3 in a row, then we extract the pieces and just take the 0th one, because we know if they're 3 in a row, they're all the same.
Yeah, that's what we showed the computer.
Right, exactly. What we told the computer.
Tic-tac-toe.
And so if we get through all the lines and we haven't found a 3 in a row, then we return none. So there's no winner. Yet.
Yeah.
And so then
they say,
all right, so then there's a winner, and then the other way it could be is a tie, which we sort of have over here when the length of the possible moves is 0. So we can, that's another, we can make that into a function. So tie is when there's no possible moves. And so now,
and so it has one.
right. So this should actually work, but it's still, so let's just try this. I haven't really changed anything. 4, 0, 8, okay, so that worked. But now we want to change it so we take advantage of the fact that we know whether it was a winner, someone won, or whether it was a tie. So how about we do this? If tie returns, now we're going to return 2 values. We're going to return whether the game is over, and we'll return who the winner is.
What you mean by return tell us?
Return to whoever called the function.
Like us?
Well, it's all us. We're writing the program.
The computer is telling us. I guess we taught it. But it's your computer.
How about this? So winner board. Okay. So if there's a winner, then we return true and the winner. Otherwise, if it's a tie, we return true and none. And it's true that the game is over, but there was no winner.
Yeah.
And then otherwise, the last case is we return false.
So that means
game's not over. No winner.
So it's like at the beginning of the game, the computer got confused or something.
No, it just means we're in the middle of the game. Because we're going to ask, this is something we can ask whenever we want. Here's a board. Is the game over? And it's going to tell us, yes, the game is over because X won. Or, yes, the game is over because it's a tie. Or, no, the game is not over. Okay?
Can we try?
So we can actually, we can sort of try right now. We'll just print the game over Let's do this. So while true, over is game over board. If over,
Why do you keep writing board?
because we're always passing the board into these functions.
Yeah, that's right.
Because it's all of these functions are like questions or things we can do with the board. Here's a board. Can you please print it out? Here's a board. Can you tell me if the game is over? Here's a board. Can you tell me if it's a tie?
Can we ask, like, is it a tie?
Yep, that's what we have with this function up here. Tie.
That's what it's called?
Yep, could be is tie. I don't know sometimes.
Is tie?
So we'll just do so this is a little bit silly, but so basically in our infinite loop, we get is the game over. If it is, we're going to print it out, and now we're going to print out the answer that we got from is game over, just to see it. And if it's not over, then we make a human move, then we get it again, do the same thing. So now let's see what happens.
Oh, what's that?
Oops. Except syntax error. I forgot a colon. No, what's going on here? If I don't know if that's actually the problem.
But you're going to fix it anyway?
Oh, sorry. I just forgot the colon, but I put it in the wrong place. There we go.
Okay.
Alright. Oh. Game over. False. So what's going on here? So if
You
okay.
forgot to tell it that.
Nope, right. Forgot that is game over, and now we just changed it, so it returns two values, right? Both whether the game is over and
Or is the board empty?
no, or who's the winner if it is over.
Yeah. Or is it tie? Right?
Well, so the first value is always is the game over, and the second value is always either the winner if there is one, or none. And so if the game is over and there's no winner, then we know it's a tie.
Yeah, because
So we can actually,
friends. And we made this.
and that's just how the logic works, right? So now actually we can do this. So we can say the winner is, and put that there.
For a second, I thought you were going to like whiner.
Yeah, the whiner. All right.
That's the least. And I'm going to write like X around.
All right. Let's remove 4, 8. Oops. Oh, I did the wrong one. 0. The winner is X.
Yeah. Okay, now let's try to loop. Or no, let's try to make it a tie.
Okay, commit that version. Tic-tac-toe. We want to try and make it a tie. Okay, so we will play. Let's play there.
Oh no, let's ask it now.
Ask it what?
If the game's over.
So I mean, we have a function in the program that can do it, but it's actually asking all the time. Every time it makes before it makes a move, it checks. Okay, where should we go to try not to win? Right down there.
Yeah.
So what's that saying? Oh, we want to let it give a chance to win?
No. I want to make it a tie.
Make it a tie.
Yeah.
Okay, so we'll go there so it can't possibly win. What's that? 3, 1, 2, 3,
5.
5. We're going to block it down at 6. And the winner is none!
Yeah! It worked.
Cool. All right. So it works, but it's a little bit gross.
Gross. I don't think it's gross.
Well, there's a couple things. So 1 has 3 in a row. We don't use anymore, so we should take that out. 3 in a row we do use. And then the thing I was thinking of is gross is that this and this are actually exactly the same. So that's always a sign that we should break that out into a function. Maybe check winner. Well, that's a little bit of a problem though. So, because this break only works like you can't break from this from a function that you call. It's got to be right in the same function that has the while loop. So we'll need some other way to tell it should stop. So we can kind of do this.
Stop.
So if over print and then game over. I mean, we could just be kind of gross and just exit. But that's a little bit, well, let's try that and see if it works. I suspect it will. Block this.
Block this from winning. Yeah, let's block it from winning.
Oh man, this computer's getting good. By accident.
Probably because it learned how you win.
Don't think so. Okay, here we go. Game over. The winner's X, and then it stops. So, but that's a little bad because like it's not such good form to like exit the whole program. Like down in some. It'd be better to like let this function play because like what if we wanted to call play game and then play another game, and it would be kind of annoying if it exited the program as soon as the first game is over. So here's another way to do this.
Because we want to play again.
So let's take that exit out. Okay. And let's do this. Human turn true. So if it's the human turn, human move, human move equals false, else, computer move, human move, true. So now, instead of checking the winner twice, we're going to, let's see what we're going to do. Okay, so all true over winner equals, now we're going back, so is the game over? If the game is over, basically I'm putting this thing that we pulled out, I think I want it actually back in, because now I can do this break to get out. So if it's over, print out the winner and break out of this loop.
For the moment, I wasn't really thinking. I wasn't really listening.
Kind of spaced out.
Yeah.
Yeah, that can happen.
I was thinking about Harry Potter.
Alright, let's see if it's okay. So let me review what we've
I was
done
thinking about trying to find my old Harry Potter robe.
Your Hermione wig?
I was gonna wear that. It's too annoying.
That's pretty uncomfortable, huh? Okay, let me just review what we got here.
Make up my
And then we'll be done. Let me just show you. Okay, so now when we play the game, instead of having sort of like check and then make a human move, check, and make a computer move, we're only going to make one move through each time through on the loop. We're just going to keep track of whose turn it is. So basically the loop is like whoever's turn it is, make a move. Actually, the loop is check if the game is done. If it's not done, whoever's turn it is, make a move. go to the top of the loop.
So it's like a very small circle.
It's a very small circle. But so the only thing we had to change is we had to keep track of whose turn it is.
Well, don't we already do that?
We just added it. You might have been paying attention then, depending on when you spaced out. Okay, so.
But Daddy, the thing I don't understand is when we're keeping track of that already, did the computer know when to move?
Only because we had sort of wired it that like call the human move function, then call the computer move function.
So why do you add that?
So in the loop before we used to do both moves. Like the loop was in the loop, check if the game is over and make a human move, check if the game is over, make a computer move, then go to the top of the loop. So we did 2 moves potentially every time through the loop. Now we want to have just 1 move per loop so that we only do the check-in 1 time.
Okay, so it's like human moves.
And then the next time through the loop.
And then go to the top of the computer.
Right. And so the way we do that is we have this variable, human turn.
A very small circle.
Yes. Human turn that tells us whether it's a human's turn. And if it is, then we call the human move function and set that variable to false.
Okay.
And actually, I'll show you a trick in a second. And if it's not the human's turn, then it's the computer's turn. The computer moves. We set the move to true. And then when we're done, we start print the code. No, actually, that's fine. No, print the board, then print the result, and we're done. Okay. So what did you say last time? You want to try and lose? Oopsies.
Yeah.
What happened there?
I don't know. I wasn't paying attention again.
Human turn.
That says turn.
Thank you. Turn. There we go.
Isn't it move?
No, human move is the function. Okay, we're going to try and lose. So we'll play at 1. We'll play at somewhere that does us no good at all, like 8. We'll play at...
no, whatever that
3.
is. Oh, yeah. No.
3 plus 3 is 6, right? 6. And 2. Okay.
I was trying to make the...
Yeah, no, that'll probably be for another day. So let me just show you one last trick. So see how here, like when it's the human's turn, after we've done it, we say human turn is false, and after the computer moves, we say human turn is true. So things that are true and false, you can flip them very easily. What's the opposite of true?
False.
It's the opposite of false.
True.
Okay. So now, instead of...
But can't you switch it so one is false and one is true? Like, like the first 2, like, I mean,
so basically, after we've made both the moves, we're just going to set human turn to be not, like the opposite of whatever it was before. So if it was true, it'll be false. If it was false, it'll be true. You could also have written that with a bang, the exclamation point.
Not human turn.
Yep. That words better. All right. So that's pretty cool. We can try moves. See if we can force the
Forcing?
Oops.
What?
Oh, that is right. Not quite where I meant to go. But, all right. I'm going to leave the
go.
maximum opportunities for the computer to win. We'll go there. That was dumb, computer. Let's at least keep you from going there. And now He goes there, he wins. Oh, whatever. He blew it.
He's so bad at winning. And we're so bad at losing.
Yep. It's easy to get a draw.
It's just a draw.
A tie.
And it's easy to win. But it's hard to lose. I was thinking about, because I think I lost my class from the Hogwarts thing. Do you think that's the robes or the cloak? I can't tell.
Yeah, this guy just won't win. I don't know. All right, so let's. What do we have left here? Oh, let's clean that up. So we pulled out check winner because we were doing a bunch, but then we decided to move it back. So that's probably okay. All right, so let's check that in.
Now do we have to add it on like our little videotape?
All right, so
I'm done.
we're done for now. Later on, if you want to come back to this, we can like try and make the computer a little better at playing so it can actually win.
Yeah.
And then eventually we can make the computer so it will never lose. It will always at least tie.
At least. That will be very hard to win then. But at least make it a little smarter. Because it's like impossible for it to win.
Yeah, it could win by lucky chance, but no, not a very good chance.
No.
All right, cool. So let's finish this up. Over
I'm
here.
gonna go look for my Hogwarts thingy. I can't tell if it's robes